Hello everyone.
Hello.
Thank you so much for joining in the live. I'm Shantanu and with me I have Miriam today. And today we are
Hey.
actually going to talk about her research. So this is the third episode of Keeping Up with the Universe where we talk about the research that is happening on the frontiers of astronomy and bring it closer to people like you and me. So before any further ado, let's give the mic to Miriam so that she can introduce herself. Hi Miriam, how are you?
I'm great. Thank you so much for having me. My name is Meriame Berboucha, and I'm a first year PhD student from Imperial College in London. So originally I was born in London, but now I live in California and I work at the SLAC National Accelerator Laboratory. And I do plasma physics, and that's my field of research. And I've been in the US for like 3 years now. But yeah, that's what I do. Thank you.
So that's awesome. So you've been like you're also a student of Imperial College and also at the SLAC you're continuing your PhD. Right. So how
Exactly.
does it feel to be an international student?
So luckily for me, the language is the same.
Hmm.
So moving to the US wasn't that difficult, but I will say like little things like in England we have free healthcare. In the US you don't. The American system means like at work people tend to work earlier, whereas in England I feel like people start later. So there's these little differences that kind of like make a huge difference when you're working here, but I mean, I have sun all the time, so whereas in London it rains all the time. So I think it was fun to come out here. But if I was to tell anyone, I would say like don't let your opportunity stay in your own country. Like look outside. Like it was such a huge learning curve for me to move to the US and like just be independent. I didn't know a single person coming to the US. I was on my own, and I would definitely recommend it. It's a huge like thing to do, and you learn so much about yourself.
Okay. I'm sorry. I just got disconnected a few seconds ago because of some internet
Okay.
issue. Am I audible right now?
Yes, yes, I can hear you.
Perfect. 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 Yeah. So as you were saying that the language barrier is not there, so I guess that jump was easy.
Mhm.
But keeping other things in mind, I guess it's always there are certain challenges to being an international student, right? The culture changes, as you just mentioned right now. So today, though, I would let my followers know that we are going to concentrate on her research life specifically, right?
Yes.
So in the middle, we'll be, taking a slight deroutes to what she does in her personal life to get a little break from all the research that she's doing. But it's going to be more of a place where we play 21 questions, but the only difference is I'll be the one asking the questions.
All
So
right.
I have 21 questions lined up for her. And if you're watching this and you want to ask her something, then you're welcome to put those in the comments. And every now and then I'll take them up. So let's begin. So the first question, Miriam, that I have for you is that let's start by knowing what is your research about. So what's the basic hypothesis that you're working on?
So in a nutshell, I look at something called warm dense matter. So warm dense matter is inside our own planet, inside the interior. It's inside a planet Uranus. It's inside Neptune. And what I do is basically try and recreate those conditions found inside those planets, but in the lab. And so, luckily for us, the physics on the small is the same as the physics on the large. So what we do is we recreate those conditions in the lab on the small scale, and then you use something called scaling laws, and you project it to the astrophysical scales. And that way, without going, into space, because that's difficult, we can find out what happens in space without having to send a probe or anything like that. So my field of work is called laboratory astrophysics because you do astrophysics in the lab, so that's basically what I do, and I'm looking more specifically about what happens inside our Earth. And so I'm excited about doing that stuff. And what's special about this work currently is that people don't know what warm dense matter is. And to give you an idea, warm dense matter lies between a cold solid, so we're all familiar with solids, but then
Right.
some people don't know what plasmas are. So plasma is found in the sun, and in between there is this gray area that we don't understand, and that is called warm dense matter. And so scientists don't know that much about it. So I'm an experimental scientist So I want to do experiments to find out more about that state of matter. And you'll ask me another few questions where I'll tell you why it's important. But yeah, that's what I do is I look at interiors of planets, but I do it in the lab.
That's awesome. So, I've read that Neptune and Uranus, these are the one of the least understood planets of our solar system. And I have two questions right now in my mind that, first of all, because we call them ice giants,
Yeah,
so there is warm matter inside them, right? And
exactly.
also, you said that this physics of the small is similar to the physics of the big. So I'm assuming that things over here, though they are very small, they are not as small that the quantum, fluctuations would take over.
So for
Or does that
warm dense
interfere?
So warm dense matter actually does have some quantum effects, which is why it's so difficult to model. So that's a great question because yeah, warm dense matter lies between a cold solid. So we understand solids pretty well because we're surrounded by them. But yeah, warm dense matter has some quantum effects, which when you start to model that computationally, it starts to become very difficult. And so currently we don't have any good models to model this matter, which is why I come in and I do experiments to then feed into those models and help people understand what's happening because we don't really know what's happening. And I think that's the beauty of science is that we can do experiments, run simulations, and then find out what happens in stuff that we don't know anything about. So that's a great question. And yeah, like you said, icy giants. Yes, they're called icy giants, but yeah, inside those planets, because of all the gravity, you get immense pressures and temperatures and densities. And so that's why this matter is called warm dense matter because it is warm. It's not hot like the sun, and so that's why we call it warm dense matter. So those are great questions, and it basically it's a hard thing to model, and there's loads of stuff in science that is hard to model, but we can do experiments and hopefully that allows us to find out some answers.
Wow, that's so interesting. So, including this episode and the previous one, I found out that there are more than one ways of doing astrophysics, not just looking through the telescope. So, last time Rose came and she told me she does astrophysics by doing maths. And over here, you have introduced me to something called laboratory astrophysics, right?
Exactly.
So that's something that the first thing I've learned new in today's episode. So with that, we move on to the second question, which is, why did you choose this topic for research? What's so special?
So for me, well, I went to university, and at university I fell in love with lasers. And with lasers, you will be surprised what you can do with them. And I found out that we can, with high power lasers, recreate stuff that happens in space, but inside, like on Earth. And so I
Right.
found that fascinating. And I was like, okay, how do I do this? Where in the world can I do this? And that's kind of how I ended up here in California, is because I found some professors that were doing this stuff, and I was like, I want to do that. Can I come, please? And I basically was allowed to come here, and I was very lucky to do that. So I, yeah, fell in love with lasers, and then the rest kind of fell into my lap. And one thing I would say is just follow what you're passionate about, and that's what I'm doing now. Is I'm passionate about this, and I love answering questions, and I'm very curious. So this is a fun topic for me.
Right. So you like answering questions. So I guess you're going to have a lot of fun right now.
Yeah,
And the
exactly.
only thing I knew about lasers is, I use lasers to play around with my pets. So now there's a deeper thing that you could do. You could learn about the interior of planets. Super
Exactly.
cool. So I think over here, our viewers are already curious to know that how do you carry on this research? So that's the third question I have for you. How do you carry on the research using lasers?
So this is where we get a bit more detailed. So tell me, stop me at any point if it becomes too
Sure, sure.
complicated or anything. So we have high power lasers, and by high power lasers, this means that if you shoot and focus this laser onto like a metal foil, you can heat it up to the temperatures and pressures that are found inside planets like our own planet. So that's what I do is I shoot this laser at a metal foil, it heats it up, and then it turns into this warm dense matter state that we were talking about earlier. Then, so keep that in your mind, we then produce x-rays with the same laser beam. And you can do that by shooting a laser beam at another piece of gas, and then you can make electrons move inside that gas. And when you have moving charges, so moving electrons, for instance, you can produce radiation, you produce X-rays. And so with those X-rays, you can actually take pictures, and you let those X-rays pass through that warm, dense matter. And then you can take snapshots of what is happening in terms of time. So that, if that, hopefully that makes sense. But basically,
Wow,
like,
yeah, it
we
does.
take pictures with X-rays that were produced by lasers of warm dense matter that was produced by lasers. So that's kind of in a nutshell how we do these things. Is lasers are a huge part of my life. My master's was actually in lasers. So that was a good grounding for me to then go into this field where I use lasers all the time.
Awesome. So, could you give us the figures of how high the pressures and temperatures are created in your lab?
So off the top of my head, so warm dense matter lies between, it can be very like small pressure, so earth pressures, to up to 1 millibar. So that's like 1 million times the kind of pressure on Earth,
Wow.
or so like very high pressures. We go to quite high temperatures too. Sometimes we can exceed the surface temperature of the sun. So we can do that too in the
Wow.
lab. So basically, anything that you see in space, those conditions, we can do in the lab as well with lasers. So yeah, those are kind of rough numbers for you.
That is so cool. So, temperatures hotter than the sun and pressures million times more than those found on
Yeah,
Earth.
like that. Yeah, yeah, basically.
So, this metal that you're using, does it have to be some special kind of a metal or slash alloy?
So for me, the Earth has loads of iron inside it, so I look specifically at iron. But if you want to know more detail, so when inside the lab, we have to make targets. And these targets is the iron that we're looking at. And for us, a target means what is the thing that we're trying to investigate. So that's the target for us. And the iron has to be placed because it's so thin. So we work with like laser pulses and X-rays, and we have to bear in mind like how much do these X-rays pass through, how much is reflected, how much is absorbed. So they have to be a specific thickness. So for us, it's kind of like as thin as a piece of hair is how thin our targets are. And then this iron, because it's so thin, we have to actually put it on a mesh. And so the mesh is like also as thin as a piece of hair, and they're sandwiched together, and that holds the metal foil on top. And then that way it's rigid enough and strong enough so that we can then shoot it. So yeah, I love these questions, by the way, because nobody ever asked me these detailed questions. So I love this.
I have no idea why someone doesn't ask you these questions. Like
No,
I'm
yeah.
left like this. Wow, it's such amazing thing, right? So we don't usually think that something like this can be done on the surface of Earth, but you're doing it over here. So moving on to the next question, which is question number 4. That is, can you tell me anything interesting about your research, something that you've
Oh.
come across while doing the research?
So one thing that people probably don't know, especially if you don't know what warm dense matter is let's go into energy. So energy for us at the moment, we can have solar power, we have like coal powered power plants and things like that. But some of you might have heard of fusion. And so fusion is the process that happens inside the sun. And that's the process that kind of emanates all of this photons and energy and light all coming from the sun. But we can do that on the Earth. And one process that you can do this with is with lasers. And so that is called inertial confinement fusion, or ICF. And when you use those lasers to produce fusion on Earth, warm dense matter is created in the fuel that you use to produce this like fusion process. So if I
Right.
do research in warm dense matter, we can then find out more about how we can achieve fusion on Earth. And hopefully that means we have clean energy because, there's not many like waste products from it. And so hopefully
Right.
one day, maybe my research will add to inertial confinement fusion and we'll have fusion power plants around us. And then we won't be, producing CO2 into the atmosphere and things like that, or burning coal. So that's one exciting kind of byproduct of the research that I do.
Well, I think I'm going to end all of your answers with me exclaiming, wow. So,
Thanks.
I guess any environmentalist watching this, you could just look into what research she's doing and how, fusion reactors could become a possibility. But I had this one doubt that when fusion happens, it releases a large amount of energy, right? So, does it create some kind of a domino effect of energy being released more and that further feeding into the system or something like that?
Yeah, that's exactly like how basically the sun works too. But instead, what happens is you have like energy release. And so, like the light that you see coming from it, that kind of dampens the process. And so that's why the sun isn't like exploding. And the same happens inside like a fusion reactor, is like actually all the process happens in like a small kind of area. And so,
Right.
you don't lose that much energy because it's like going through all the like plasma inside, and it loses energy that way, and that's why it doesn't kind of like explode and stuff. So yeah, that's exactly right.
Wow. Okay, so over here, one of our viewers has asked that how exactly is this ICF done? So this fusion thing, how is it done in the lab? How does the lasers help in?
So actually, where very close to where I live is the largest laser in the world. It is the size of three American football fields, and the beam is
Wow.
huge, and it's focused like I think it's like 192 beams are then focused onto a fuel pellet. And so normally, if I'm correct, it's deuterium and tritium fuel pellets, and the laser is focused actually on two sides. So it looks like a little like cylinder, and they're focused on the two sides. And the laser beam heats up this process, the fuel. It makes X-rays. Those X-rays then heat up the fuel even further, and then that excites the material inside and excites this fusion process. And that's basically how that is ignited, and that's how the fusion is. Well, we try and do it in the lab. I don't think it's been achieved for long periods of time. So that's what people are doing, is using high power lasers to achieve fusion that way.
Awesome. So this research can, I really look forward to this being carried ahead, even in terms of the fusion energy and not just exploring the depths of the planets. So
Yeah.
something interesting, we have interdisciplinary science going on over here. So I guess a little bit of the next question has already been answered by you, but I'd like you to elaborate on this. That what kind of equipment do you use on your research? So we know one is lasers. What else?
Yeah. Yeah, the lasers are the main part of my research, but I work a lot with mirrors, different shapes of mirrors. So I don't know if you know what a toroid is, but it's basically like a donut shape. We can kind of cut a slice of that donut shape, put like a mirror coating on it, and you can focus X-rays with that. So that's one of the main components that I'm working and modeling at the moment, is a toroidal mirror. I work a lot with lenses. I wear like laser goggles when I go in. I have to be gowned up, so I wear a lab coat, a hairnet to keep my hair, because basically any dust or anything else that is going to hit any of our optics, because it's such high power lasers, they can burn those surfaces. And this equipment is very expensive. I have equipment that is like $10,000, some $100,000. So I don't want to ruin them. But yeah, basically anything that you've seen like lenses or mirrors, I work with hundreds of those things. And if you were to look at one of my experiments, we have a chamber, and this is the vacuum chamber, because obviously in space everything is kind of in a vacuum, and we need
Right.
to recreate those conditions too. And the chamber I work in, the vacuum chamber, I can go inside it and sit inside. So it's about 2 meters in diameter, and it's cylindrical. So the scale of the experiments is very large, and I think some people don't think, how big these pieces of equipment can be. So yeah, I work with very big things, and in America everything is bigger, so it's even bigger than when I was in England. But it's a lot of fun.
Well, so this is the first time I've heard about the toroidal mirrors. So do you cut it like horizontally or vertically?
It's actually, so if you, I wish I had a donut with me. If you have a donut, it's actually like
Right.
this section. So you'll cut it this way, yeah, like
Okay.
that way. And then this
Understood.
side, so this curve is the mirror part, and that's what I'm modeling at the moment.
Oh, wow. Okay. Now I understood. So, you use mirrors, you use lenses, a lot of cool lasers, safety equipment, and the vacuum chamber. So,
Exactly.
is this the same kind of laser, or the ones that people have at their homes, right? The normal ones that they play with. Obviously, it's not as powerful, the ones we have at our homes, but basically the same science, right?
So the science of the small lasers that you have is actually different to what we have like in the lab well, different in the sense that like it's way bigger. And basically how a laser works is you shine a light onto a material, and that material gets excited, it produces photons, so light, and then you put two mirrors like this around it, and you let the mirror like bounce that light, and then after it keeps exciting that material on the middle, and then you produce more and more and more light, but all of that light has the same like wavelength or color,
Mhm.
and then they all kind of go in a wave in unison, and that's what classifies something as a laser, is the same color and that the fact that the waves are in unison, and so we call that coherence. And so but
Right.
the your laser pointer is exactly is exactly that. And when our big lasers is the same thing too, we just have different colors. So like sometimes I use infrared, sometimes I use green, and we have different colors in the lab. So that's, yeah, I mean, your laser pointer can do some damage too, just like these big lasers, so don't shine them in your eyes, please don't do that.
Okay, so basically the same laser, but more bigger and more powerful.
Yeah, it's way, yeah, way bigger.
And you also mentioned right now that you use infrared lasers. But I also understand that infrared is not very energetic, right, compared to the shorter wavelengths. So, is infrared useful in the kind of research that you want to do?
So infrared, because it's a different wavelength, all different wavelengths or different colors of light are absorbed in different ways. And so depending on what your target is or what you're trying to heat up, sometimes infrared is more absorbing in that material than something else. And for me at the moment, infrared kind of light is great for absorbing. And so
Right.
we use that. So yeah, different wavelengths, you just have to look at spectrum, a spectrum of like how much is absorbed at different colors, how much is transmitted or reflected, and that gives you an idea of like what laser you need to do the research that you need.
That's cool. That's so cool. So even weak, otherwise weak energetic lasers like infrared are also used in the kind of research. And we have. I was going to ask you that, can you see the kind of lasers that you're using? Can you see the beam? But then you said that yes, you use green colored light. So that answers that part of the question.
Yeah.
So moving ahead, we have question number 6 for you, and that is. So, Miriam, could you tell us a little about your academic and related journey that resulted in this research?
So at university, I did a bachelor's degree in physics. That's when I fell in love with lasers. So every summer of my degree, I actually did an internship. And in that internship, the very first one I did, I was exposed to high power lasers, and I was like, this is what I want to do. And then after my bachelor's degree in physics, I then did a MRes, so a master's of research in photonics. So just like electronics is the study of electrons, photonics is the study of photons, so light. And so basically I got exposed to even more lasers, which was great for me because I love them. And then now I started my PhD like, I don't know, a few months ago in October 2020 in plasma physics. And so, yeah, like we said before, plasma is like what the sun is made of, what candles are made of, like candle flames. So that's what I do at the moment. I want to say as well that I don't have a perfect path. I did fail my master's twice. So I want people to realize, even though I'm doing exciting stuff now, life gets in the way sometimes, but you can still carry on and still do the stuff that you want to do and never give up, and never listen to anybody that tells you can't do something either. So yeah, I don't want to put out that I'm this perfect, person. I also have struggles too, right? But I love what I do, and yeah, it's amazing.
Miriam, thank you so much for sharing the thing from your life that you failed twice in masters, because I think, I'm sorry, I think that it has been, a really encouraging thing to know that even though you might face failures, right, on your way, you can do great things, right? It
Exactly.
doesn't have to be all A grades and all gold stars
Yeah.
on the journey.
Exactly.
So I've also found, I had this question that what, according to you, is the difference between MRes and MSc? So, normal Masters in Science that is done and Masters in Research. And does it really make a difference?
So the reason I chose an MRes, so Masters of Research, is because I'm not good at exams. I tend to work better when I do research. And so a Masters of Research, so my degree had 65% of the weighting of my grade in research work. And that's what I was like, yes, I can do well, because if it's research, I love it and I excel in that. But as soon as you give me an exam, I cannot do it. So an
I can
MSc,
relate.
yeah, an MSc, a Master's in Science, has more exams than an MRes. And so I decided to choose an MRes because I was like, I don't want to do exams anymore. That I still had to do some exams, but like it was way less than an MSc. In terms of like degree, like I don't know, like specialty or anything, they're very similar. And I wouldn't, for me personally, I wouldn't choose between the two. It was just for me, doing more research made more sense for me, and I could manage that better. So, but in terms of like choosing, if you're good at exams, do the MSc, if you're good at research, then do the MRes. And so I would recommend that.
Thank you for sharing that. I wish I knew that before, I started my masters, and I think we can bond over our, mutual hatred for
Oh,
exams. Because just 2 years ago, I had appeared for my exams in masters, and I actually failed, and I didn't get into any college.
oh
So
no,
I started my
yeah.
masters this year. So
Okay.
I hate exams.
Yeah. Well, good luck. I wish you all the best for your masters.
Thank you so much. I hope I get through the exams because I'm going for an
Yeah.
MSc.
Fingers
Fingers crossed.
crossed.
Yes. After your journey, the next question wants. Okay, yeah. So the next question that I have for you is, what could be the implications and follow-ups that result from your research?
I think we touched on this beforehand, is the
Right.
biggest impact is ICF, so the fusion. And yeah, like we said, warm dense matter isn't really known, or we don't know that much about it. So if we can find out more, then hopefully that allows us to do some fusion on Earth, give us clean energy, and that will be great. But also just in terms of like, we're curious beings as humans. We want to know more about what happens in our environment. And I think a lot of us, and I think as well for your podcast and all your viewers, we like to look up at the sky and we like to
Right.
know what's happening. So I think for a lot of people, this research is like, oh wow, we know this about the planets around us and stuff like that. And you never know, if we find out something that could be useful for something else on Earth, we don't know that, like, and that's why we do
Right.
experiments in science, is to find out something new, and maybe it helps us live better qualities of life, or whatever it is. So I think with any science, there's always going to be some impact from it, I think. So, yeah.
This was more about the fusion, but I also wanted to know that during your research, while you studied, the interior of our planet and other planets, is there something, curious or weird that you came across? Okay, this is happening inside these planets. Is there something like that?
At the moment, so you mentioned right at the beginning the diamond rain. We had a conversation before this started.
Right.
So with the same research that I do now, you can actually produce what we call nano diamonds, and inside Neptune, there's diamond rain, and so we can find out basically what happens inside these planets with like the stuff that we have on Earth. And I think we can try and manipulate and change things about our experiment, and hopefully from like what, I don't know, NASA gets from their probes and stuff like that, we can try and relate those and be like, oh, maybe we think it will be like this. And so there's so many different environments that we can like predict and like theorize and see what happens. So yeah, the diamond rain was like one of our biggest experiments in my lab. It got the most press because everyone was like, "Oh, you make diamonds in the lab? That's really cool." So yeah, there's so many possibilities in science, and I think it's very cool.
Yeah, so over here I have an expert scientist verifying that yes, it rains diamonds on ice giants. So these diamonds that you're making, are they big enough so that they can be used in jewelry? Or there's no fear of someone
I
stealing them.
I wish so. I have a funny story. My very first time into the US, I was at the immigration border and the guy asked me, "What are you doing?" And I was like, "I'm making diamonds." And he was like, "Are you like, what are you doing? Are you making a company with
Wow.
these diamonds?" And then I explained to him that actually they're nano diamonds, but they also exist in like a blink of an eye. So they appear and then they disappear as quickly. So I wish we could, keep them because I would make a diamond necklace, honestly. But no.
So you also use the opportunity of, being in the immigration to educate some other guy.
Yeah, exactly. I love
Yeah,
educating
go
people. I
scicomm.
love, yeah, exactly. Yeah. Yeah.
So, okay, so let's hope if the diamonds someday in the future exist for a longer time, Miriam, where to contact me,
Yeah.
and
If you
I'll just
see,
send you
yeah,
my
if
postal
you,
address.
yeah, and if you see me with a diamond necklace, you know I've achieved it and I did the experiment well.
Right. So, taking that conversation forward, we have question number 8 for Miriam, which is the main object, right, that your research focuses around. Could you tell me something interesting about that particular object?
Something that we haven't covered already. Let's see. Because yeah, for us, it's all about that warm, dense matter, the stuff that we don't know much about. And that is interesting because we don't know anything about it. And that is basically the main object currently for us. And funnily enough, the same way that I mentioned I use lasers to produce X-rays, we can also use those x-rays on the side for medical physics. So not only, like, I think some people think like one experiment is just that experiment, but there's so many side objects too. So one of the side objects, and I know I'm digressing from the main object, but we've spoken about the main object, but one of the side objects is you can actually use those x-rays to image like capillaries in your body or bone
Wow.
structure. So there's also, yeah, there's like kind of parallel science that you can do with something that you create. And I focus a lot on these x-rays that were being produced. And I also try and optimize those x-rays either for the warm dense matter, but my research group has also like used them for, yeah, imaging bone samples in 3D. So there's a lot of cool
Wow.
things that you can also do on the side. So I also love medical physics too. And I couldn't decide between the two, but my field at the moment can do both. So I can always choose to kind of go one way or the other. So I think that's something cool about. So sorry for changing your question, but there's side objects that we can do too.
No, absolutely. That's okay. So, you have both your feet in two different boats, one
Yeah,
about laboratory astrophysics and one medical physics. So you create
exactly.
3D pictures of cartilages and bones. So if I'm picturing it right, we have the lasers and the X-rays falling from one direction on a main object, and
Hmm.
just perpendicular to it from the other direction, we have another set of X-rays that create a 3D picture of the capillaries and the bone structures.
So it's just literally you can do it with one beam. So you have your lasers onto a gas. Those produce the
Okay.
X-rays. Those X-rays go through the bone, and then you have a like a camera, and then that X-ray camera takes those images, and you change the bone like position, and you can get these different slices and images, and then you make a 3D image from those images. And so that's how they did
Wow.
it.
So we have some biology over here also. So I should have mentioned it, right? Even biology fans can come over here. It's not just for astronomers.
Exactly.
So after all of this happening, so much of fun going around, and also a lot of responsibilities, and I'm sure there's a lot of work pressure also. So amongst all of this going around your research, how do you balance your research life and your personal life?
I'm grateful that you have asked this question, because I think for a lot of PhD students, even like students like yourself doing a master's or even a degree, it's so important to take time away from your work, because you need to refresh. And I fall into this trap of like working, working, working all the time. And sometimes I forget to take that break, and then I feel tired, I burn out, And so what I do now, because I've gone through the system of like education for a while now, is I make sure I try and do 9 to 5. So I start at 9 in the morning and then try and finish at 5. If it goes to 7, I'm like okay with it, but at 7 I have to stop, because I need to do something different before I go to bed. Like, I don't know, go for a run, do something else. And the weekends for me, always off. I never work on the weekends unless I have a big deadline and I haven't done enough work yet. Then I will work on the weekends, but I try and take them off just so that on Monday I'm fresh and I'm like excited to do what I do, because I think as well, if I work too long, sometimes I can be demotivated just because I feel stressed or whatever. So for me personally, it's so important to take that weekend off. And even if I work long hours during the week, at least I have the weekend to kind of rejuvenate and then start on Monday.
Right.
So yeah, I would recommend that. I mean, everyone is different in how they work and stuff. But yeah, I try and take my evenings off and my weekends off.
Okay, so that brings me to the question. So what do you do on the weekends? Usually, like what's your
um,
usual weekend schedule?
So before the pandemic, I would dance a lot. I love salsa dancing. That's one of my biggest things. I love climbing, so I do a lot of rock climbing. I love singing, so I do
Wow.
that just in the shower. And well, I love being outdoors. I was always someone that like goes to bars, socializes, meet up with my friends, go to pool parties, just I'm a extrovert to the extreme. So I love being surrounded by people. But yeah, one of my main hobbies was dancing, and I miss that the most during this pandemic, is being able to dance, outside and stuff. So yeah, I loved,
Right.
and I recently though picked up roller skating, so I'm doing that at the moment. And yeah, that was what I used to do before the pandemic hit.
Ah, great. So I guess you've started roller skating after the pandemic, right?
Yeah,
Something new you're
exactly.
learning.
Only a few months ago. I'm not that good yet, but I'll keep trying until I get better.
All the best. Roller skating is very fun. I used to do it as a kid, so I know
Oh,
the joy of
nice.
falling down, running around.
Yes, I have fallen many times.
You will, and you'll fall many times more. And I guess there will come a point where you'll just start enjoying this.
Exactly, yeah.
So moving on. So we've almost completed, half of our interview. So we are at question
Yeah.
number 10.
All right.
I, I really did not realize how time was passing by, because I feel like we've been going a little fast, because I want things to go so slow. It's being so interesting. I don't want this conversation to end.
Yeah.
But nevertheless, I guess we cannot just sit over here and trying to, make the interview longer and just wait that this communication keeps going on.
Yeah,
So
exactly.
I'll move on to the next question. That is, what are your tips for communicating a research paper in under 5 minutes?
So I had to write this down because I wanted to make sure I remember everything that I wanted to say. So for this
Okay.
one, I would say you need to remember and answer what your problem is. What are you trying to solve? like what is the heart of your paper, like what is that question that you're trying to answer. So you need to
Right.
remember that. And then the next thing is like, why is it important that you solve that question or answer that question and you communicate that? And then the last thing is how you did it, how you managed to answer that question. So those are the three main things that, yeah, when I'm trying to communicate stuff. So for me, as an example, I would say, so what is the question I'm trying to answer is what happens inside Earth? And then the next thing that I have to say is, why is that important? Well, if we know about what happens inside Earth, well, first we answer that question of what happens inside Earth, but also by knowing about this thing that we said, warm, dense matter, we can also connect it to fusion. And so that is the like, why is it important? And then the last question is how you solve it. Then I would talk about the high power lasers. So for me, if I was, yeah, trying to describe a paper in 5 minutes, those are the three main questions that I would answer. And hopefully that kind of gives your audience the idea of what you're trying to communicate and what you've done.
Yes, because a lot of people who are in the field of academia, they are going to be in a situation where they have to talk about their research,
Yeah.
and because you've been doing it and you're personally related to it, you have a lot of things to tell, and for you, everything is interesting. So it takes a lot of mental effort to filter all that information out and understand what is important for the person who's listening to.
Exactly. And also on top of that, it depends how you're presenting it. Are you giving a talk? Are you giving a poster? Or are you just talking to a room full of people and it's more casual? Are they in your field? You know, you have to think about your audience, like what their level of, understanding of your work is going to be. And so all of those things adds to how you describe stuff. So like to I don't know, like a school children, I would definitely not talk about, all the depths that we've been talking about right now. And so
Right.
yeah, you just have to bear that in mind when you're talking about your research too.
Yeah, I hope this, people who are in research are going to use this to their advantage. And it's very impressive. You're the first guest who's written down notes for herself during the interview. So you've done your homework.
I like to be yeah, I like to be prepared.
So carrying on, we have question number 11 for you, Miriam, now. So we are entering, yeah. So how do you deal with mental blocks during research and try to stay mentally healthy?
Very good question. So I am somebody that suffers with anxiety. It's a very common thing, and so if anybody is listening to this at the moment, I hope that like you're able to talk about it. And I think this is one of the biggest things that I've realized is that in academia, I've always been told if you have mental health issues, you shouldn't be doing a PhD, which I think is totally wrong. I think if you get the right help and you ask for support, which is what I've been doing, especially during this pandemic, is before I was very, I don't know, I found it difficult to ask for help because I was embarrassed that I had this. Um, and so I think personally, I hope that this anybody is watching this and does suffer with anxiety or anything else, that they are able to go out and ask for help. You're not alone. There are so many others that are going through this. You have people that care about you as well. And so I think that's an important thing that I wanted to just kind of bring to this conversation is it's okay and you can support yourself and manage through whatever you are going through and still be able to do your science or your career or your job. And I think that's something that I want to change in academia is people telling you that you can't do something because
Right.
you suffer with something or whatever like that. And the number of people that have told me that I shouldn't do my PhD because I have anxiety is insane, and I think it's so wrong. And I hope that I am somebody that's going to tell all of you that you can do it and don't listen to anybody that says that you can't. And to answer your question about how do you deal with that is you well, when you ask for support, you kind of, for me personally, I know I need to take breaks. And if I see myself getting tired or anything like that, and so this also ties in with the mental blocks. I will get a mental block if I'm too stressed or, I'm getting anxious, then I take time off. And if it means I take Friday off, then I will do that. If it means at, lunchtime, I'm just feeling too, I don't know, stressed or anything like that, then I will take that afternoon off. And I think it's so important to listen to your body. And You know, if you need to take a nap, go take that nap. If you need to go for a run, go take that run. And I think you ultimately, and your health is the most important thing. And I took me a time to realize that, you know, I cannot be 100% if I'm not looking after myself. And I think it does take time to realize that and prioritize that. And it's only when I've gotten older that I'm like, okay, I need to prioritize this. And I work better and I am better as a person and as a scientist if I look after myself. And I think it's so important to remember that.
Right, and thank you for sharing, how you do it. And I think it's very important for everyone to understand that taking care of your mental health is very important. And I even personally, I feel that the idea that if you're suffering from anxiety or any mental health issue, you should not go into academia, because on the contrary, a lot of people whom I follow on Instagram and they are doing research, a lot of them have shown some kind of, they've shared a story where they have told that they
Mhm.
are facing anxiety issues. So it is something very common. And I feel that, even the people who say that, anxiety is something that should not be there in academia, I think even they suffer from some kind of stress, some kind of anxiety. And, they just put on this false shroud to cover their sickness, because they have been told the same thing, that, it's not supposed to be. But I think anxiety is very common if you're in a field like academia, where you're going to be put in, in such a place where it's actually very competitive, and the pressure to guess the correct cause for a particular result. I guess that's going to get through you, right? You're going to be anxious for obvious reasons.
Yeah, and I think that's why I share it on my Instagram, because I think for a lot of people it's like, oh, she's doing a PhD, she's at Stanford, you know, Imperial, and doing all this stuff. And it's like, yes, I am doing this stuff, but you know, there are some hard bits too. And I think well, it is hard sharing both sides, because I have to be vulnerable and I have to be strong enough sometimes on days where I'm like, this is scary to share. But I think it's so important, because when I was at school, I had to read blogs because I was like, I don't understand why I'm feeling like this. Like, I didn't understand my anxiety as a kid. My parents didn't really like accept it either. And so I read blog
Mhm.
posts. And so for me, I'm like, I'm trying to be that person too, is like share my story so that somebody else that might not have the support or, you know, knowledge of what is going on, that they have someone to be like, oh, I experienced this. Now I kind of understand what this is, but also that you can still carry on and do your job. Like, and I think that's so important. And especially in academia, like you said, it is a stressful environment through and through. And yeah, just being open about, you know, we do struggle, and there's so many people that do struggle as well. And yeah, like you can still do it, and just, you know, ask for that support and help. And there's so many people around you that are either going through the same thing or are willing to support you.
Yeah, and as you said that it was as a kid you used the internet to get answers to what you were going through and what you were facing. That also, makes me think about the fact that if we did not have the internet, solely the internet was not there and everything was the same, so this pandemic would have been very hard for a lot of people, right?
Yeah.
The internet is what, made us realize, okay, what I'm feeling is completely normal, right? It's not
Mhm.
something I should be ashamed of. And okay, this is how they got help. Maybe that thing can help me, because not
Exactly.
all of the people facing mental health issues are going to have access to medical experts and things like that, so they get
Exactly.
an idea in a secondary way, that how can
Yeah.
I help myself.
Exactly.
So a while ago you just mentioned, right, that you're not going to use the same terms, same details if you're in a room full of school students, right, to share your research. So that brings me to my question number 12, that how would you explain your research to a kid?
So if I was surrounded by school children, I would bring a laser pointer, and I would say that if you imagine this laser pointer 10 times, 20 times, 100 times bigger. And imagine that hitting like metals. You can produce what happens in a planet with lasers and with that laser pointer, but a stronger version of it. And with that, I can find out what happens inside our planet, because I heat up stuff. Because just like the sun that heats us when we go outside, that same energy is allowed to heat up metals or things like that. And then we can recreate those pressures and like temperatures and environments, harsh environments inside those planets with the laser. And so that's what I would probably say. And then I would also bring in some props where I normally put like pop balloons with lasers and stuff like that to show that you know lasers can be powerful. So that's what I would do. Oh, I think you're muted. Sorry.
Yeah, yeah.
Yeah.
I think this question is going to be the easiest one for you because the moment you bring laser in a classroom, you have all the attention, right? So
Exactly.
they
Yeah.
okay, the moment you say I point lasers at stuff, students are like, okay, I want to do that. That is the research I want to
Exactly.
go
Yeah.
into.
And that's how I was at university. Somebody was like, I can explode things with lasers. I was like, okay, I want to do that.
Don't tell me more. I'm sold. Moving on to our question number 13th, which is what is a major problem or an obstacle you faced on your research to get the data or anything, and how did you overcome that particular problem?
So in my field, how it works is you write a proposal, and that proposal is you asking for time at, for instance, like I work at a national lab, and there are many national labs all over the world. And so this piece of paper, the proposal, is a few pages long, and you say, this is the experiment I want to do, and this is what I want to carry out. And so the biggest obstacle at the beginning is the competitiveness of writing this proposal and being accepted to do work at a beam tent. So that's problem number one. Problem number two then is once you get accepted, you need to plan out this experiment to the T because you are going to have, so for instance, I've been awarded beam time, I think going to be in December this year or early next year. But it's a new facility. I've never worked there before. And so from now, I only got accepted a few weeks ago. So I've been cramming all of this work to basically prepare for this experiment. I need to plan it so hard. And so some of the hardest bits is sometimes if you don't prepare or plan enough, you can go in there and you're not going to be prepared. And then you might not get the data that you want. And so that can be a difficult bit as well. And then in terms of like actually getting data, sometimes the laser breaks, something else breaks, something burns, and loads of things can go wrong. And I think some people don't realize that it's not easy. Like it's not just, you know, put the laser on, you shoot, and that's it. There's so much work. And so I've been on an experiment before that's taken 10 weeks. So that's 2 months and a half
Wow.
of time to do an experiment. So I think, yeah, one of the biggest kind of misconceptions of this work is that it's not just fire a laser at something and that's it. There's a lot of work that goes into it. And sometimes it can take a few years to prepare for an experiment. So that can be a hard bit
Right.
about this stuff.
So I have two questions now.
All right.
First, you said things get burned.
Oh my
Elaborate.
God. Yes. It's the worst part of an experiment is sometimes you might forget something because there's so many components. So I wasn't joking when I said there's hundreds of mirrors or stuff or lenses that I work with because inside the chamber where we do our experiments, I'm working with hundreds of optics. And so it's very hard to remember, you know, have we blocked the beam? Have we, you know, taken into account like this energy here and there and like all of this stuff? And there's a lot of stuff to remember. And that's why we collaborate. We want more people so that we can, you know, be able to carry out experiment. It's a lot for one person, and that's why science doesn't work with one person. So I have had experiments where things have burned because we forgot something, and it's just human error, and it happens. And sometimes you lose $10,000 worth of a mirror, and this stuff is expensive, and so it can be disheartening when it happens. But yeah, that can happen.
Okay, so like things getting burned, but what I was imagining is maybe some kind of a Hollywood movie going on in my mind that, something got
Fire.
burned and, yeah, fire. And, you're trying to just put it off. But okay, so yeah, even if it's not of that big scale, it can, cost a lot of damage. As you said, the equipment is very costly and
Yeah.
things like that. So I actually forgot what my second question was. Uh,
Right.
Yeah, I just remembered. So you said that one of your experiments went on for 10 weeks, and I'm assuming that in between one day and the other, you were going to switch off your equipments, right? So do you carry on from the next point, or it has to start from zero? How do you start from the point where you left? Because everything's going to cool down, or like maybe I'm I have zero knowledge about this, so I guess you understood the question that
Yeah,
I
yeah,
have.
yeah. So the reason why things take so long is like I said, we work with hundreds of components. And so sometimes it can take 2 weeks to set everything up. So we were talking about my toroidal mirror. That has 3 stages that we have to put it on. We have to assemble everything. And so even if we have 10 people, sometimes it can take a while. So even just setting everything up. And bear in mind, every time you put a mirror, you have to align the beam. You put another mirror, you align the beam. And it can take very long time, even if you have 2 mirrors, to get the beam to be straight or like at the same height and where you need it to be. And so that's why it takes so long, is because every time we put something in there, we have to test it. We have to align the beam. We have to check everything. We have to take images. And so that's why it takes so long at the beginning. And then when you're taking experimental shots, so that's where you take your data, that can be a bit quicker. But if something breaks or something misaligns, imagine the beam is going through hundreds of optics. And so you
Yeah.
have to align again. And so normally the laser only really turns off if we finish for the day. And then, yeah, it takes time for things to warm up again, and things like that. And also, even overnight, if we leave things, things can move. But because we work in like microns of distances, so very small, small distances, anything can move, and we are prone to earthquakes here too. So things like that can change an experiment. So, we're working with very small distances, but it means if something moves, we have to start basically from the beginning to align everything and then take those images again and things like that. And so that's why sometimes it can take a very long time.
Okay, so like out of the 10 weeks, most of it was actually setting up the whole experiment properly and accurately, right? And the main
Yeah.
experiment is going to be on the final day when everything's set up.
Yeah, exactly,
Uh,
basically.
yeah,
So,
you were saying something?
oh, I was just going to say that there's a running joke in physics that all of your best data happens on the last day, and every experiment so far I've done has happened on the last day.
Happened on the last day.
Yeah.
So you said that your laser only switches off during the end of the day, right? So I'm thinking that it's on and you guys are like going around it. So if and I have messed up questions like these in my head every time. But if someone gets in the way of the laser, how long is it going to get to get, for them to get seriously hurt?
Well, it depends if the laser is focused or not. So if the beam is really wide, you won't have that much damage. But if it's focused, that's where you start to get burns and things like that. And I think you'll feel it very much instantly. And especially if it's in your eye, you are going to lose part of your vision or even all of your vision if you get it in your eye. Especially because my lasers are quite intense. So yeah, don't do that. And whenever there's a beam inside our lab, we are always very, very careful. And one of the things or the problems that I have is I'm a short woman, and sometimes the laser beam can be in my eye level. And so
Oh,
what
wow.
happens is sometimes I can be in a situation where I have to work on a stool because I otherwise it's risky of it going in my
Yeah.
eye, so I have to be careful.
So I guess you have all your adrenaline rush inside the laboratory. You do not have to
Yeah.
go outside and do some kind of extreme sport.
No.
This was a fun thing to ask. I should put questions like these. How can your experiment harm someone?
Oh my
Okay,
goodness.
just for anyone who's watching, I do not have a criminal mindset. I'm just a very curious person. So coming on to our next question, which is question number 14, which is assuming the research takes you into academia and teaching, what are your opinions on that? And are you comfortable in the classroom? And what are your hacks to being a good educator?
I love teaching. I have so even things like this I consider, a form of teaching or a form of science
Yeah.
communication, and I love doing stuff like this because I think that at school it's very limited what you learn. And sometimes you don't learn that, like, there's so many exciting things that are not on your curriculum that you learn at school. And so for me, my job as like a science communicator is about giving awareness and like knowledge to people about things that they wouldn't necessarily learn at school. So for me, that's the most exciting part about this. And ever since I was like 17, 18, I would go back to my school during my degree, during my master's, during my PhD, and give talks. I even hosted a science club because I was the only girl in my physics class at school. And so I was told that, you're a woman, you shouldn't do physics. And I was like, no, I love this subject, I want to do it. And I went back into the school because teachers were saying that to students that, like girls shouldn't do physics. And I was like, we are not letting this happen in the school. So I did the science club and I had so many young women in the classroom and it was amazing and super fun. So for me, I think that aspect is really close to me because I was at school and I was told I shouldn't do this subject, which I think is very wrong. I think if you're excited about something, you should be able to do it. So
Yeah.
that's where for me, I love education. And I think if you have a platform and share your story. If you're doing something cool, why not, share it? And I think for me personally, sometimes a selfie can be so powerful because you put a face to the science and it's like, oh, she looks like me, I can do that. And I think, yeah, there's not that many women. There's also not that many women of color who are in this field. So being able to share my story for me is such an important thing because I don't know, when I was growing up, I didn't really have role models around me. So I appreciate things like that. And so to answer your question, I am very comfortable in the classroom. I love educating and I wish I could, even now be in schools, but I love that we have this kind of platform now where we can do it online. And I think I can educate more people that way because, the internet is an amazing thing. And then you say, what are your hacks to being a good educator? I think understanding your content is key. If you don't understand it, you cannot communicate it. So for me
Yeah.
personally, you need to understand what you're trying to communicate and then think of analogies. So think of ways, when we were talking before, you were asking about numbers of like, how hot does my stuff get, People understand
Mhm.
things with everyday objects, which is why I always relate things to things that we are, when I talk about plasma, I say a flame or the sun, because it's something that we as human beings have in common. Like we know that stuff. And sometimes as scientists, we can, in our field, we have, all our special words and, special numbers and units and things like that. But to everyone else, we need to find something that we all have in common. And so, yeah, when you're educating, you need to relate it to, that's why I bring a laser pointer because everyone has seen one. And that's why I use that to communicate. And so those for me are, understanding and also analogies and relating to objects around you are my two key things. And yeah, if you don't understand your work, don't even try and communicate it because it's not gonna work. So yeah, those are kind of my tips.
Yeah. Yeah, so obviously, if you do not understand that what you're trying, what you yourself are doing, or what you yourself are teaching, it's going to get hard. So either you're going to turn into a bad educator, so you're going to stop your students from asking questions, right? So you don't get stuck. So you're just, repeating things that you memorized. Otherwise, you're going to get stuck in uncomfortable situations, right? And
Exactly.
it's up to a point. I guess it's okay to not know the answer to a question
Yeah,
because
of course.
that's going to tell you go ahead and read more. But when
Mhm.
you lack the basics of what you're teaching, then it's going to get problematic.
Yeah. And I think that's an important thing that you brought up is also if I don't know the answer to something, I should say I don't know. And I think that's important
Yeah,
rather than spreading wrong information. And I think that's an important thing too.
very
So
much
yeah,
so.
thank you for bringing that up. Yeah.
My pleasure. I've been into teaching myself, so we
Yeah.
do come across situations where someone gives out a wrong information, and that's
Hmm.
actually not very good because the students are going to take your answer for the word, right? They're going to
Exactly.
trust you.
Hmm.
Uh, moving on, we have our next question. This is one of my favorite questions. So, what is the most recent new thing or news that you have learned related to any topic? It doesn't have to be
So
about astrophysics.
of course. So yeah, I had to write this down too. But um, so I don't know. I don't know about you guys, but I love following NASA news. And so we know that
Yeah.
Perseverance was on Mars, but they are trying to basically launch like a helicopter on Mars. And that will be the first time that humanity has launched a powered, controlled flight on another planet. So I think that's incredible. Like, I think that's such an amazing achievement, and that is actually scheduled for today. I don't know if it's happened, but
Yeah.
so hopefully that is going to be successful. But they want to do it before Wednesday. So I thought that was an exciting news because it is today, and that's going to happen today. So I think that's a very cool piece of news.
Yeah, that's very exciting. So you just said, Perseverance is launching the helicopter, which is called Ingenuity. So
Mhm.
when the moment you brought it up, I was like, okay, shit, I forgot it's today, and maybe I missed it.
Yeah.
But then I remembered that because NASA is going to talk according to their local time. And I remember in one of the posts they said it's going to be before 11th April gets over, right? So I
Yeah.
guess you still have time for that, right? So when
Yeah,
it's
for
night
me,
at your
yeah, I
place,
think it'll be your
yeah.
morning. I think it's
My morning
yeah,
tomorrow.
yeah, yeah,
Yes.
exactly, yes.
So I have a fingers crossed. I'm very excited for the launch of Ingenuity, right? Whether it's going to fly, what's going to happen. Yes.
Exactly.
So if that works out, probably they'll start thinking about sending helicopters to Titan, and
Yeah, that would
all
be
the other
so cool.
places. Yeah. So Titan's, it's a very exciting moon with all those seas and the oceans. And I actually learned, you do not need a spacesuit to be on Titan.
Whoa, I didn't know that. That's very cool.
Yeah, so the atmospheric pressure over there is actually the same as here on Earth, but it's a very smelly
Ah.
place. So on the
Yeah.
top, where if you are tall, so over the top you're going to have some sweet fragrance, musk or something.
Uh-huh.
But if you go down, you're going to smell all sorts of decomposing
No.
smells.
Yeah. Oh gosh.
So moving on, so the next question, yeah. So next question is, if it was not for this subject, what would you choose to do in life?
In another universe, I would actually be an interior designer or like a fashion designer. I love my first career that I wanted to be in is like an artist, and I love like creating things, and I think that's why I do science communication, because I get to create my own content, describe things in my own way, and I love being creative. And I think that's why a lot of people in my career were like, why are you doing physics? Like, you're a very creative person. But yeah, so in another universe, I would be an interior designer or a fashion designer.
Wow, yeah, so that's a very unexpected answer. Usually people, they give a subject, but that's under the whole niche of science. So I would like to ask, as someone who's into fashion designing or interior designing, have you done, have you posted some content related to that, which we could check out later?
For me personally, I express my creativity through like my hair, my makeup, and my clothes, and my Instagram, I think, shows that. So all of my pictures are, I don't know, me expressing myself. And I might post sometimes some of my art, so you'll see that sometimes in my Instagram too.
Awesome. So I guess today we are going to have a few people scrolling down your feed. We are going to check out all the art that you've posted. I also feel art is a very good way of, escaping reality, getting a
Yeah,
break
for
from all that regular
sure.
schedule.
Yeah, exactly. For me, it's like singing and art get me, out of a stressful situation. So yeah, I agree.
Yeah. And what kind of art do you do?
Um, I personally am very, well, I enjoy just pencil drawing and like still life. Like, I sometimes go outside and I like drawing whatever I see. I love drawing nature. Um, but recently we've been getting into like pendulum art. So that's a bit of physics in there, where you basically have a string, a bucket of paint, and
Ah,
you let
yeah,
it
yeah,
just kind
understood.
of circle. So yeah, I do that as well currently.
Well, that's cool. So you have like I'm assuming you have all this set up in a very big room, right? So you'll have to
Yeah.
string it.
Yes.
Awesome. So I'll be waiting for the next time you post a picture of that.
Yeah, I will do.
So, moving on, question number 17. So, we've come a far way along our interview, and this question is, Is there any particular piece of misinformation or pseudoscience that is common and pisses you off?
I don't know about pisses me off, but like for me, it's the misconception about how big lasers can be. Because we're so familiar with like laser pointers, excuse me. And so I think most people think like, oh, your laser is just a laser pointer, and it's like, no, these lasers can span big, big rooms. And so yeah, like I said before, the biggest laser in the world is the size of 3 American football fields. And I think that's the biggest misconception. I'm like, no, I don't work with laser pointers, I work with lasers. Like they're very big things. And sometimes I think some people don't really, understand how big the lasers can be.
So, even when I was reading about this research, I thought, the laser would be something maximum as big as my table, but, I'm sorry, very strong to focus the light. But the moment you told me that, there's a laser which is as big as 3 football fields, I was like, wow, I don't want to be around it.
Yeah, I mean, I haven't visited, but I can imagine it is insane.
Obviously, yeah. But this is a misinformation. Is there any pseudoscience that you commonly face or hate?
Um, I think a lot of people don't understand that like you can, create conditions found in space in the lab, and I think a lot of people think that that is like an insane concept. And so a lot of my work is very much like, oh, I didn't know you could do that. And I think that's like a cool thing to be like, yeah, yes, you can. But yeah, I think in general, just school doesn't teach you enough. I feel like, at least when I was at school, and I just, I'm all about just getting this cool information out there. So yeah, I think just read about stuff that you're interested in.
Yeah, I think the curriculum in schools, a lot of schools is still outdated, right? They're still following the
Yeah,
same curriculum
exactly.
that was taught to our parents, and the same is being taught to us. So it needs to be updated, right? New things should be
Exactly.
included, and things that are no more relatable should be put out of the syllabus.
Exactly. Yeah, I agree.
Talking about pseudoscience brings us to the next question that what are your views on science communication, and could you share some of your experience with that?
So I started science communication because like I mentioned before, I was the only girl in my class, and people were telling me like you shouldn't do physics, this isn't for you. And so I wanted to like share this journey that you can do it. And so I started posting like on my blog post about like how cool my science was and like why I was interested in it. And then it blew up, and so ended up getting loads of followers, and now it's just this amazing community, and I think it's great. And so for me, I think it brings people together, and also for me it's a point of like inspiring someone. Like, what if they're not supported well? Can my account be someone that they look up to and that they do? Excuse me, I've just been talking for so long, my
It's
throat
fine, it's fine.
hurts. So yeah, for me it's just about like inspiring people, and that's why I do my account.
Yeah, so I think with me creating this account, I've come across a lot of people like you who have been using, this amazing platform of social media to communicate science.
Yeah.
And I guess social media has played a very important role in making science communication also a, possibility for all the scientists. Because usually, otherwise, even if I talk about as a professional scientist, you would be mostly attending talks that are attended by people who are already in science, right? So I
Mm.
think they need a little less push compared to people who are not in science, right? In terms of
Yeah.
science communication, especially students who obviously wouldn't be attending your talks and all your posters and things like that, because obviously it's out of their reach, it's out of their capabilities. So
Hmm.
we need this platform of Instagram, where all of these kids are there, and out of all the fun things they find, they also find some fun science.
Yeah. I think as well, one thing I want to add is the how I got to the US is I actually tweeted someone. I so somebody gave a talk at my university, and I was too scared to ask them a question because I was very shy back in the day. And I tweeted them and I was like, your work is really cool. Like, how can I go there and do the work. And he was like, you should come. And so I think as well,
Wow.
science communication and like just social media in general can lead you to opportunities as well. And I think that's a misconception too about social media. Like it's just about, you know, very vain things where everyone's like showing selfies and things like that. And it's like, no, like I'm somebody as well that, like, you know, if you ask me a question, I will try my best to answer it. Or like I have numerous people message me and being like, how do I get to Imperial? How can I get to SLAC where I am now? And I will tell them like how, you know, I think they could try and get in and stuff. So I think as well, social media can be this incredible place for opportunities. And I think some people don't realize that. And yeah, that's how I got to California. It's from a tweet. So yeah, try it out.
So now I'm going to begin tweeting to all the people whose lectures I've attended, right? I'm probably going to
Exactly.
spam them. So talking about the same thing, moving on. So you said as a child you did not have a lot of role models, right? But I'll ask you this question: that is there any scientific figure of inspiration for yourself, maybe now, and why do you look up to that particular person?
So up until very recently, I didn't have like any women in my research group. And so for me, my figures of inspiration are the women around me who are doing the science that I want to be doing or the positions that I want to be into. Excuse me. And so
I think please drink a glass of water if you have
yeah.
some around you. I think you need some water now.
This happens to me all the time if I speak for like a long time. It always happens to me. So hopefully I can get
Uh,
through that. We have two questions left, right?
yeah, we do.
Oh my goodness. I'll get through it. But yeah, so it's all the women
Yeah,
around
catch
me.
a breath. I think you should catch a breath. Take it easy.
Thanks. But yeah, for me it's like all the women around me. And I think I look up to them, people that have children and in science, or yeah, people who are leading big teams, I look up to them. And I think those are the female figures around me that I look up to.
That's a wonderful answer. Because a lot of times, even if someone's answering that, there are, women in science in the past who have inspired me. But I also think it's very important to talk about people who maybe not have, famous names or famous personalities, but
Yeah.
still mentioning them. That science as a whole is mostly run by people who are not famous per se, right? So these are the parts of the machinery. So
Yeah.
thank you so much for acknowledging all the women around you in powers of position, position of powers. I'm sorry. Yeah, so
Yeah.
who've inspired you. So moving on with that, we have our second last question. And this is something everyone would want to know, that what is one advice you would want to share with prospective graduates?
So I wrote some things down too, and I think so for me, I was told I would never go to university. And so um one piece of advice for me, at least for me, is like believe in yourself. Like you know yourself. People don't know all the story about you, you know? And I think at least for me, so I'm going to be a bit more real at this moment, but when I was 16, I was taken out of education because of an illness for 2 years. So every teacher that taught me was like, you're not going to achieve anything, you're not going to go to university. And I believed in myself, thankfully, and it's a very hard thing to do and it takes time. But I just didn't like how everyone around me gave up on me, didn't believe in me, and I was like, no, I can do this. And so I work super, super hard. And I think for people to realize, like, to me, there is no such thing as clever. I think there is hard work, there is dedication, and also knowing how your brain works to learn effectively. And so I think, you know, for me personally, I like to work with colors when I study, or I like to have visual things when I study. And so learning that changed the game for me because I can't sit in a lecture theatre and listen to someone. I don't learn anything that way. And I think there's so many people that learn in different ways. And if you learn how you learn, then you're able to learn effectively and you can do so much better. But also follow what you're interested in. So many people were like, you know, physics isn't for you, you shouldn't do it. And I think I love the subject and I wanted to do it. And I think, you are going to live your life. And so you are the only one that you should listen to, basically, in terms of what you should do. And yes, you can take advice from other people, but if somebody's telling you no, don't listen to them and get rid of them. Don't have them in your life, because you need support and you don't need people to bring you down. Another thing that I have done maybe a bit too much is experience. So go out there, like I said, tweet someone, I don't know, email a professor, maybe try and get experience. And so for me, being able to do internships made me quickly realize that I love lasers and that's what I want to do. And I think being able to have experiences allows you to realize what you like and what you don't like. And then it allows you to funnel into what you enjoy and then land you into a place or a career that you really like. And so for me, during my degrees, it was so important to have internships and things like that. And I know they are very hard to get, but if you can get them, they can be very, very valuable in like allowing you to learn what you like and what you don't like. And so let's see what else I had written down. Oh, as well, I think because everyone can, everyone in your degree has the same degree. What makes you stand out is your experiences. And so I think I can't emphasize that enough, is like, try and get an internship. And even, if you message somebody on Instagram, ask them how they got to where they are, and I'm sure there's so many people that are happy to answer. Like, I'm definitely that person. I am happy to answer that question. And even if you want to ask them about their research, and that's why this podcast is so great, because I get to share this research, and maybe somebody else is like, that's what I want to do. And it's great, and I think there's no harm in, asking a question. The worst that's going to happen is they don't answer, but you keep trying until get out there, use the knowledge that is the internet, like search for things. And there's so many things out there that are available. Like, you can code online and have a free coding course. The internet is such a great place, and I think use it and use social media as like a networking tool, discuss with people, ask questions. And so those are my tips, is like get experience.
Thank you so much for sharing those, wise words. And I think it's very inspiring of you that, even after a 2 year gap, which is very much, right? People, I think that's the point where you may break or you may come out stronger. And I think it's very inspiring that you still did not listen to what all the other people were saying and, chose your path. And today you are over here, you're, educating all of us. And, your advice at this point really matters. And I think a lot of people are now going to get inspired by your story, because it's something a lot of us relate to. We do not relate a lot to people who've been very successful, right? But you always relate to someone who's faced that kind of criticism, or someone like I said, at this point I'm relating so much with you hitting exams, failing in the past. So I think that is going to give us hope that just keep at it, keep trying.
Yeah, exactly. And I think as well to remember, so I came from, well, so my parents are immigrants and they came to the UK, and I am so grateful to be in the UK too. But my parents didn't know what the education system was like. So I had to ask people how it was going to be, like how
Yeah.
university was going to be. I'm the first to go to university in my family. And so, you know, my parents didn't have enough money. And I was lucky that, in England, we are supported that way. But so many other people are not. And I think,
Yeah.
well, I hope there are opportunities for them. But I think, if you don't ask, then you don't get. And there are, so many people that are happy to help you. And I think that's important too. And also to realize, you don't have to come from a rich background, or, my parents don't have to live in a certain country to be able to do what I do now. And I'm very fortunate that, I have had opportunities. And I think, yeah, there's so many people that will help you. And I think when I was growing up, because my parents didn't have money, I was so ashamed and like just like, oh, I won't be able to, come to Stanford. I wouldn't be able to go to like a good university in England. And I thought that, that background was gonna stop me from doing it. But don't let, your background or anything like that stop you from achieving what you want to achieve. And I personally am a believer of like, you can make things work, you can make things happen. And it's just about, going out there, ask those questions, really fight for what your dream is. and you'll be able to get there. And like we said, you will have failures and you can get back up and you can carry on. And you can still do it. And I think that's a great thing to remember, is that, you can still do it and there's always a way, at least in my opinion.
Yeah, and now, despite all the difficulties that you have, you are now a student in Imperial College, right? One
Mhm.
of the best institutions that you could have. So amazing, right? After, I guess, I was true when I said it before, that after every answer, I'll be using one of the words like "wow," "amazing," "that's
Thank
cool,"
you.
and I'm at a point where I'm just repeating myself. So I guess, like every good thing, this interview has come to its last question, and
Yay.
this is: if you could suggest one book or an author of any genre to someone, what would it be?
So I have chosen the book What If by Randall Munro, and maybe we
I
can
love
post it or
that
something.
book.
Yeah. So, so you know what it's like. So, okay, for me
Yes.
personally, at school, you're not taught how to think in like a physics way. So, and this book allows you to think outside the box, and it allows you to kind of see things in like a different way. And I think, like it answers some questions like, you know, can you hide from a supersonic windstorm in Finland? Like there's these crazy like questions that he
Yeah.
answers with physics. And so I think that is great because that's what physics is about. It's about, and science in general is about asking these hard questions and like, yeah, what if that does happen? What, how do we figure out what will happen? And I think that's what's great about this book, is it allows you to think in that like problem solving way, and I love that book. So tell me about your experiences with the book.
You made me so excited and worked up for this book. I was like, yeah, I've read it, and I read it when I was in my third years of bachelor's.
Oh,
So
nice.
that was the year I took this. Your new year promises to yourself. So I took the promise that I'll be reading one book every week, right?
Hmm.
So it was one of the last books, and it was one of the books I loved. So for anyone who's listening right now, this book answers questions that otherwise you would call stupid, right? For example, questions like, did you know if you hit a ball at the speed of light, the earth will get destroyed, right? And it's so amazing. And he says, okay, let's assume this earth does not get destroyed. What will happen, right? Let's assume if this happens, what will happen if people are jumping on one end of the earth?
Yeah.
What would happen to the right? And it's not actually. I think I've forgotten a lot of things that were taught in the book. So I'm going to go back now because you brought it up, and I'm definitely going to do a post about it very soon.
Yeah, I love that book and I'm glad you read it too. I need to read it again too, I think. So my physics teacher gave it to me and it was great.
Yeah, so you've had a good physics teacher, lucky student. So, with that very interesting answer, our interview comes to an end. We are out of questions. And I hope everyone watching this and who will watch this enjoyed this as much as I did. I had a great fun. So, before we end this talk, Miriam, is there something you want to say to our viewers?
Well, thank you so much for having me. And also, you are all amazing. Keep, fighting for your dreams. You have unique skills and you can achieve what you put your mind to. And I think remember that you are unique and special. And yeah, good luck with everything that you want to do. And thank you so much for having me. This was so fun.
That was completely my pleasure. Thank you so much. But I'm so sorry. I'll just stop you from one last question that a viewer has put up. And he wants you to tell us one last thing that you would like to say to our viewers.
I can't hear you if you can still hear me. Oh no. Oh, okay, you're back. I think I can hear you now.
I'm sorry, I lost the connection over there.
No worries. I can hear you now, so that's good.
Perfect. I'm so glad it did not happen between the interview. Yeah, so I'll repeat the question that was there. And the question was, where did you have more fun doing research, back in the UK or the US? And this is in reference to the equipments, etc.
So I wasn't lying when I said everything in America is bigger. In the US, they have, well, at least in my experience, more money and more equipment, and everything is bigger and better. So I've enjoyed working in the US more in my research field and in the lab here because yeah, everything is just shinier and bigger and better, and so I've enjoyed it way more. But not to
Bigger
say
the
that,
better.
yeah, exactly. But not to say that the research in the UK is bad. It's just, and I'm in California, like I can't complain. Like it's super sunny and nice, and so at the moment I would say that I have preferred it in the US. Thanks for that
I guess
question.
there's the answer. So I guess that because of the spirit of competition that is there, in the US, they always invest in the better things.
Yeah,
So I guess there are no other questions. So thank you so much, Miriam, for being a part of this interview.
you're
Agreeing
welcome.
to donate your time of the weekends that you usually take to escape from research, but I've made you talk about your research. So thank you so much for coming, and I'm sure any question that comes up, I'll put it your way.
Perfect. Yes, please do. Yeah, thank you so much. This is so fun. And yeah, if anyone has questions, follow me on Instagram, ask the question. And I hope you've all had fun. And I love this podcast, and I think it's a great thing. And keep doing it.
Thank you so much. And yeah, I hope I keep coming across, scientists like you. And for anyone who's watching, the social media links of Miriam are right now sliding below the video. You can see it over there. And if you like the interview and you want to check out what I do, so I make comics about space. So if you like comics and you're into cartoons, you can go check out my social media from the description below. So thank you so much. I'll see you in the next interview. Bye bye, everyone.
Bye.